Good day, everyone. Thanks to all of you for joining from so many different parts of the world. And we're happy to have you here at today's Virtalis Industry Meetup, where we will focus on the engineering domain. John, how are you doing?
Doing good.
Excellent. I was just checking your mic, so welcome here. So,
Yep,
um,
I'm here.
this opening video is actually from Edge Hill University, and who's educating engineers of the future, on VR and XR. And they're using Virtalis software and solutions to train them in getting this very important competence on board. And experts believe that the half-life of skills is now about 5 years, which is actually another way of saying that everything you learn will be redundant to some extent in 5 years from now. And 60% of current jobs are expected to become automated or redundant in some way. And while we don't expect that the engineering domain or engineering at itself will ever disappear, we do believe that VR and XR are core competences, which are a crucial set of an engineer's toolkit. So that's why we started with some of our educational customers. But today we're going to focus, John, on the industrial enterprise and dive deep into the possibilities of VR and XR. So, on behalf of our speakers and panelists, I'd like to thank you, all of you, for joining. And while I say that, I have a look at the count. So we have close to 250 registrations. Many of you already dialing in or signing up. We have a packed agenda, so there's no time to wait. In the next 1.5 hours, we will share stories, talk about case studies, talk about specific views on how XR is accelerating the engineering world. I would like to take a brief moment to introduce the external speaker. So we have Stuart Clarke. He will join us in a minute. A genuine change agent, spent 26 years at Ford and pushing digital transformations. We have Jim Shaw. He spent 20 years at Bentley, and when he left the organization, he was the chief digital officer and started his own company, Bloom. Jim will also join us later for the panel discussion. And we have John Martin. I would say there are many ways to introduce John, but he's a world-leading pioneer and basically among the first in the world applying virtual reality in the previous century for the shipbuilding and the submarine design. And he will share his case studies from BAE Systems. So I will do more introductions also with the other team members and suggest we'll get started. A little bit about myself. I'm based in Holland, primarily working on the leadership network that we are building with customers, partners, and experts, where we connect, share stories like we're doing today, to learn from each other, to enhance ourselves, but also to further the projects of the organizations that we are working on. And I'm happy to see, while the count is still going up, to see many of those leadership network members also attending this session. So, what's the plan for today? It's a very exciting agenda. We will look at the scope. I mean, the importance of time to market and the impact, continuous impact on the engineering function. We'll also decompose what these design reviews are and why they are important. John and I will kick this off. And we have some very interesting examples and case studies today. Looking forward to Stuart's version on how Ford is deploying VR and the specific advantages, but also having John Martin talking about how we did it. They did it in the old way and how they moved to new ways of working at BAE Systems. We also have demos from Vestas, where I also see live design reviews in action and how that can be used and is being used. And we'll take you along in a very important aspect, which we believe John will personally present that on collaborative XR and how distributed team members can be connected and work together in concert on real powerful model. But the fun is at the end, John, and we have a poll and Q&A, and we would like to make sure stay on board. We have poll questions, and join us, become part of the discussion. Jim and Stuart will be there with John on the panel, and we have an exciting closure of this this session. And we are very keen to get your inputs and hear your inputs also on the future. I mean, we will look at what's possible today, but how will the future look like? A bit of householding, very briefly. I mean, the format, our industry meetups are about engaging between you and our panelists, experts, customers. So please use the chat and the question box during these sessions. If possible, we will address your questions on the spot, on the fly. If not, we will move them to a panel discussion and a Q&A. And while we have close to 250 registrations, it should not prevent you to engage, network, and get in touch with the experts on board here. Okay, John, I would like to just take a few words on Virtalis. I mean, not all of us who are present know about this. We are a pioneer and a global leader in advanced visualizations. We are typically known for working with large organizations, but also one of our more recent products, which is cloud ready, cloud enabled, is now also heavily adopted by smaller and medium-sized enterprises. And I think it's fair to say that we have a very strong foothold in the industrial enterprise, and I show some key areas as well. So some of the facts, we are here pioneering for quite a long time, experts around the globe, customer-centric approach, and our headquarters in the UK, but we're having representations in basically all continents where our partners and customers are. Key areas of expertise, I think we are and we will learn about it more, the undisputed leader in the design and the engineering domain. And today we also like to share with our customers and experts why and how we make that happen and made it happen over the last 25 years. And we will show you as well the new cloud capabilities of our software as well. So 2 years ago, we started building a dream to put XR and VR basically in the hand of every relevant person in the enterprise and beyond the enterprise, hassle-free, easy with the click on a button. And we will show you today how that works and how that is represented in one of our software products called Virtalis Reach. While this will not be a commercial presentation, while we focus more on the business impact and the business value, you will see today how this software is put into place and what kind of value it's creating for our customers. So we're still on track, John. Can I set the stage for today's session? I mean, it's an interesting start. I mean, the concept of time to market being the time it takes to actually produce and develop a product and have it available to your customer. That's the time to market. And in 1991, back in the days, McKinsey found out that, you know, time was money, but it was not money. It was actually more valuable than money. And at that point of time, that was kind of new. So it basically means that you better deliver on time instead of delivering on budget. So 33% loss of profit if you are 6 months late, compared to only a 3% loss if you are spending 50% on extra on your budget. So that was a very interesting finding. And I think over the years, it has only become more apparent. This was the time where the HP printers, physical products were shipped. I think in today's world, it has even become more important, where you also have digital services that can be shipped at the speed of light. which also makes it more important to be on top of time to market. So, and that is, I think, one of the mantras for modern enterprises. I mean, you need to be fast, so you need to be first. And time to market, I mean, reducing the engineering and design process has basically become a continuous improvement process, a Kaizen process. So what's the impact for the engineering and design role in the industrial enterprise? Because think about it, what we'll be seeing today, if you engineer a car or a submarine, I mean, it could take years to decades to actually get that product in front of your customer. And the impact of engineering design is huge or significant on time to market. So how that is reflected is you see new emerging management theories on concurrent engineering, first time right, cross-functional teams, and specific principles on how to do it. And you see a continuous focus on identified new technologies that can help accelerate the engineering and design function. I think additive manufacturing is certainly part of that, but XR and VR driving acceleration in this function is definitely one. And that's what we're going to look at today. And with setting that stage, John, I would like to hand over to you. And before you do so, I would also like to briefly introduce you for our audience, because I mean, it's a pleasure having you here with your 30 years of experience in the engineering and manufacturing domain. But prior to Virtalis, you also founded and sold successfully your own VR simulation software business. And I glanced at your LinkedIn today and I actually found, I don't think many of us actually know, that you're also a PhD in computer science. Mm-hmm. And in 1996, your thesis was about real-time collaborative virtual environments for simultaneous engineering. So tell me,
absolutely.
Man. I mean, it's I think that's spot on for today's topic, isn't it?
Yeah, I've spent 30 years looking for a solution to this problem of distributed collaborative engineering, and we're now slowly starting to get there. It's quite an interesting journey, I can tell you. Okay, thanks, Dimitri. Let me first, I just want to spend a couple of slides before we get stuck into some real examples of this. I just want to take a little step back and look at what we mean by design review and why it's important. So typically these days, most modern products are very complicated, and processes as well, and they involve typically thousands of parts, processes, and people across multiple departments, suppliers, and so on. And these processes require a lot of synchronization in order to get all the stakeholders involved and to avoid having these all of these issues that can potentially crop up discovered very late in the process. It's all about effectively having right first time processes. This actually links back to what you were just saying, Dimitri, about the McKinsey report. Right first time is more about time than it is about money, reducing the amount of iteration by discovering problems early. So design reviews are an absolutely critical part of this synchronization because they bring together the multidisciplinary teams at all the key stages of the process and help them to achieve good alignment and establish this common vision for the products. And typically, I mean, I've outlined some of the objectives there of a design review process. So for those of you who are involved in them, you'll be familiar with this, but it effectively brings together all of the parts of the product or process from multiple sources, allows the original design intent to be properly communicated and maintained, allows them to understand the status of where everything is and what issues there may be and what the root causes will be, and then more importantly to achieve a consensus over what they're going to do about those problems and agree and document those decisions, and most importantly assign some actions out of that meeting to make sure the problems get resolved. So these are really critical, I mean you could call them project planning meetings, but they are critical meetings. If we just move to the next slide, you'll see effectively this is the old world, and I think John Martin will touch on this a little bit more from his experience. The old world, I mean, for those of you who are familiar with it, you'll be all too familiar with the old ways of working and the issues that surround it, using whiteboards, printed 2D drawings spread over a table, squinting over someone's shoulder at a small CAD screen to try and understand what they're doing. Or if you're really lucky enough, you might have a physical prototype that's been expensive to build and has taken months to construct. And of course, the problems with all of this is that these days the processes and products involved are too complicated to just explain with a drawing. You can't get the big picture over. And often, even if you do prepare physical models to help people understand these things, these incur huge costs, delays, and consequently limit the amount of times you can have these iterations, these design review meetings. And similarly, these mock-ups, because they take so long to build, they can often be out of date by the time they're built. So therefore, any discussions or decisions you make based on this model are typically a waste of time, because they're nearly always out of date by the time they're built. And one other problem is that if you're dealing with multidisciplinary teams, bringing together design, engineering, manufacturing, suppliers, then you've got the added problem of communication, because often these disciplines all talk different languages and use different tools. And so establishing common vision and consensus is really difficult. So really, what we have these days, and it's no longer necessary really to be just relying on these old methods. We now have XR-powered design reviews, and these are now becoming mainstream, if not already in some businesses. These are typically, just to describe what we mean by this, you'll see lots of examples in this session, but typically they are full-size virtual mock-ups, often at 1-to-1 scale, in an immersive environment that are designed to eliminate the need for a physical prototype. And they typically replace those ineffective methods of communication and presenting complex designs. The XR-powered reviews typically can employ a range of technologies, and these are designed to support those virtual prototypes in different types of design review environments. So all the way from low-cost HMDs that can support the home-based office workers and remote collaboration, all the way to full-scale power walls and caves that support the ultimate immersive group collaboration experience. And with COVID restrictions easing, well, in the UK at least, we can actually start to bring people together to have some of these collaborative sessions. And all the way to the latest range of AR devices, which allow us to now create what we call hybrid design review environments that combine both real and virtual models to provide, I guess, a realistic physical touch and feel, a kind of physical book combined with the virtual design overlaid on top, which allows us to see the new, but still be able to feel and touch these environments. The whole idea really is to bring those design reviews, those XR-powered design reviews, bring us closer to the real thing without us having to build a full physical model. They allow us to work faster, to reduce cost, and basically reduce our carbon footprint, which is really important these days, because we're not wasting material, but also to easily share digitally all of the latest models and the latest data, taking it directly from the design database. So we do have some really good examples, but I just wanted to put those in context. Design reviews themselves are not just, they don't just happen at the design stage, in quotes. If we were to take a look at a typical kind of generalized development process, this is what I'm showing here on this slide. Now, this is a general process, and whether we're talking about products or processes, ships or cars or pharmaceuticals or whatever, they all basically go through the same basic processes. The process starts with defining what we require during the concept phase, and these typically involve reviewing and selecting viable concepts and checking feasibility. You know, can we actually make it? Once that's frozen, it moves to the detailed design phase, where the detailed designs and all the parts and sub-assemblies are brought together and defined. And typically the type of reviews we do there are the detailed design reviews, plus also the packaging and integration reviews. And we'll see some examples of that today. And once we pass through that stage, we then transition into what we call basically the process development. This is how we define how we're going to make the product, or in the case of a process, how we're going to implement it. And at this stage, we're talking about reviewing the proposed manufacturing assembly processes, the supplier selections, the plant design layouts, and material flows. Now we're going to look at all examples of a lot of these, but we're actually going to start at the end of the process today, and we're going to explore how, for example, in this case, Ford, and Stuart's going to take us through, for example, how XR has enhanced how they work in designing factory layouts, in particular, the material flow around those factories during the early ramp up and during the operation of those plants in Ford across Europe. So at that stage, I'm going to hand back to you, Dimitri. So maybe if you could introduce Stuart and take us to the next stage. Thank you.
Yes, thank you, John. And Stuart, are you online? Can you hear us?
Yes,
yes. Hey, there you are.
Working, hopefully.
Fantastic, you made it. I mean, this is
Hi, Stuart.
Improvisation. You made it from your meeting with the US team. So thanks for joining us, Stuart. Let me do a brief introduction for our audience, and so they know a little bit about the background and what all you did and are doing. So I'd like to start at an important part of the culture at Ford, as I understood it, is to basically disrupt the norm, disrupt the standards. And if I look at your work and contribution, I think you took it very seriously as you drove the adoption of virtual reality into the material flow and packaging environment. And we will, I saw the slides, we're very interested to learn how that happened and what you realized there. And I think it's also interesting on a personal note that you are a very keen and good photographer. And you even have your photos featured in the Getty collection, and will even be published in the 2022 calendar. So while we don't have the pictures in today's session, I can tell you I'm very interested to learn more about that. But let's focus on today's session on VR and XR in the Ford world, Stuart. So I'll be moving your slides back and forth, and floor is yours.
Lovely, thank you for the introduction. You're very complimentary, Dimitri. So, as said, I've worked for Ford for 26 years, and I started as a body die toolmaker apprentice and worked my way to where I am today. And where we came out to start looking through the virtual world was that as part of one of our model launches that we did, we worked together with the plant to do the reviews. And one of the things that we started to understand was that a lot of people we were speaking to and dealing with didn't actually understand what we were talking to them about. If you do the next slide, please, Dimitri. So the way that we looked at it was that here we had an incredible waste stream in our development and deliverables, because we had to get people to sign off what we were going to physically install in a plant, and they didn't actually appreciate what they were signing off. And we'd put the installation in, and when we're talking our installations, we're talking in the region of 10 to 15,000 euros each time, and just to do it. And then we'd end up lifting it up because they'd say, that's not what I thought, that's not what I'd see. So we looked at it and we said, what have we got here as opportunities? So we've got an opportunity here to improve our cost base available on this, because we're doing things more than once. We've got an opportunity to look at and improve how our timing works, because if we can get people to buy off in the virtual world, we can get everything done much earlier and much quicker in our process. And we now use our way of doing things to drive the wider organization to say, you need to do that earlier. Where's your data? Where's your cycle line layout that drives where our equipment goes? You need to provide that to us now rather than last minute. So we resolved this by looking at what do. We want an innovative project to upskill our teams, our engineers. You know, if we're not moving forward, we're moving backwards in these worlds. So we need our engineers to keep getting their skill sets going and keep improving and keep understanding more. We looked at how we were going to use the VR environment and what we were going to do with that. And that would drive us to reduce costs. So our view that we are driving towards is that all of our design reviews will all be done within the virtual world. So when we actually produce a steel piece of equipment, a shipping rack or a set of racks, or we go to install it, there should be no changes because everything should have been done in the virtual world and everything should have been picked up. So we've got one cost. We have a waste stream of we buy racks that someone hasn't understood something on or they've missed. Whereas if we're doing the BIOS in the virtual world, we can pick the part, we can put the part in the rack, we can lift it out, we can check ergo, we can check clash conditions. And that's where we've driven to with this way of doing these things. And what we really needed to get to as well was having up-to-date environments. And we started doing this about 4 or 5 years ago. And now the last 19, 20 months have proved really how vital it's been. We're a traveling function, mostly based in the UK or Germany, dealing with a plant in Spain. I am going to the plant next week for the first time in 21 months. We've still had to install the equipment and still had to do the launches in the meantime with that. So we looked at different software choices that we had around it, and we decided to go with the Virtalis Vision Render, really based on looking at what we wanted the tool to do and what the software gave us. So we looked at VRED, and VRED was just far too complicated and far too steep a learning curve for our engineers. We needed to be an add-on for the engineers. It's not someone's specific job, it's an additional task. So we looked at them, it's import, it's drag and drop. Those were all the things that we liked about it. With any automotive company, we don't want to pay for anything we don't have to. We do pay for Virtalis, I will clarify, but we like the low cost around it. We like the perpetual license options that we can buy. We don't have to keep signing up to a subscription service like is so prevalent nowadays. And the key bit that was really important for us was we can run VisRender on our standard notebooks. We don't need an engineering workstation for what we do with our design development work. We have bigger PCs for when we put the goggles on and we walk around in the environment. But for our engineers, they can sit at their desk and they can pull up the file, they can look at it where they are. They don't need to have a specialist computer with a time slot to go to. And the other advantage we have is this was already in use in Valencia plant. So that was a copy and moving to migrate together with that. So then we looked at where have we modelled and why. So we looked around the different areas of the plant and we decided that the team working on it were most familiar with the trim and final side. So we selected the trim and final plant model. We worked with a supplier that already did a lot of our CAD work because we didn't have spare capacity at the time. They knew the plant, they knew the area we're looking at as well. There were a lot of changes because of the sheer complexity of volumes of models that run through Valencia. So it was an easy way for us to change things as well, that we didn't have a lot of, we've got to pay a supplier to come in every time. Once it's drawn, we can drag and drop things around. The engineers were quite capable of that. And we had a current layout available where it had been the plant that was the centre point of the full European transformation strategy. We had an up-to-date layout that we could translate into the virtual reality software and make an easy start with that. So we went for a few different iterations to get to where we got to with this. We looked around, what do we need to do? So we first off looked at how was the best process to do this? How was the best way to get everything in that we needed? So our core layout technology we use is the AutoCAD system. So we had the advantage from VisRender that we could bring in the DWG layout in the background and we could just have it there, drop everything on top within the system to exactly where it needs to sit. And straight away, with not much effort, we've got a 3D built plant in the virtual world. We looked at bringing stuff in from our systems. We bring everything in that we have to bring in as a JT. Another easy, common format for us. You know, we use Team Center. We can output easily into a JT from there. Again, all about how easy is it for us to get our engineers working together? How easy is it for us to get people to understand what they're looking at? The bit that we put in the VR itself was the factory walls and the hard points, so column grids. We put those in the VR. Anywhere where there's something we can't use, we took a lazy route and we put a block.
Right.
That we just signified we couldn't do. When we looked at it, took a step back for what were we learning from this? We looked and we understood that, you know, we needed, with all of our models that we ordered from a supplier, with everything we were buying, we needed to now make sure that engineers were specifying there should be a 3D model and 3D CAD drawings. That took away another stroke of work for us. So it's getting, our design reviews are just collating things together, bringing them in one place and presenting. We're not then having to do a lot of work to get there to use the virtual world. It's all part of it. Excuse me, it's the worst week in the world to lose my voice.
By the way, Stuart, 1 second. So we're getting questions. So I would recommend everyone drop them in the question or chat box, and we'll address them later on because Stuart will be one of the panelists. So thanks, Stuart. Let's continue.
No worries, no worries. So then what we understood we needed to do now, we were bringing as a group staff, which is the central core staff in full. We're not tied to any particular plant. We work with all of them to ensure the company is keeping its standards and its best practice. So we needed to get the process agreed for doing layout changes, get the communication levels done. And this is where all the design reviews kicked in, that we could do it easy. In the last 18, 19 months, where we've not been able to sit in the room and put people in the goggles and the headsets, we've been able to share over our video call system, that we can walk them through our 3D layouts, we can walk them through our virtual world easily. We can walk up to a rack, but we can't walk through it. We can check the ergo and the heights and things like that. And that was the process that we had to develop as we worked through our way. And one of the things that we took very key from it was that we looked at, this actually is going to be a very powerful tool for us for our cycle line layouts, because one of the continual discussion points we have is around allocating parts at a line or whether they should be sequenced to the line. And a lot of the time, the driver for that is blamed as space at the line side. But in the virtual world, we can create that station, we can prove all the parts fit, and we can push the responsibility back onto the process team to say, actually, you need to reallocate the part one station one way or the other. And if you do that, there's a cost saving. We can prove that to you now, that we can fit these ergonomically, the operating work, whereas in the past, we couldn't prove it. Now we can show and we can tell and we can walk through with the teams what they need to do to reduce the cost to the company. Next one, please.
Yes, here we go.
So,
yeah, yes.
Where are we? Which one are we on? Yep, next one from this, I think.
Yeah.
Yep. So what do we look at as our benefits? So we've benefited from this by making sure now that where in the past we might not have had a 3D CAD model for something, we've now got that. This is sort of a gatekeeper safety check for that process now, so that we're making sure that nothing's missed as we go through. It drives plants to share with us current level layouts, because we work on snapshots in time in our job. So we work at, that's how it looks today, that's what we have to base our studies and our costs off. Tomorrow the plant may move something, it looks different. So it drives the link and the conversation that the plants must share with us, the latest status of the works that they're doing and the standards that they're working to. It's, as we said earlier, reduced the rework for us, because the design review, the sign off, the assessments, it's all done before we're screwing anything into the floor. It's all done before we're cutting a piece of metal. And the other bit that we've done as well is it's reduced rework because of lack of understanding by engineers. Because when you can get yourself immersed in that world and you can walk around the shipping rack, you can look in the shipping rack, you can put the part in, you can pick the part up. In the virtual world, you can have it set at the right height, so you know ergonomically it's okay. We know that we're not going to have a problem when it's there later and done, you know. That's where we've gained greater understanding with the engineers as well, that they understand why we're doing this. It's not just about we're doing it because it's a toy. We're doing it because it's the right thing to do. It drives our benefits. It saves us double, triple, quadruple working on things. The next bit we looked at was Industry 4. And Industry 4 is quite key nowadays within the foremost company environment. We have a lot of legacy plants. We have modern technology within our plants, but we also have technology that's been there for quite some time. We use chain conveyors, whereas some other bits of the plants use skillet lines, and those don't aid themselves too well to things like low-level AGVs. So building these digital twins, we can start to instantly pick out where we can start putting in Industry 4 technology. We can work with the plants to say, this is what we want to do. How does that look for you? Let's get involved, get in the environment, have a look through, see how it works. We can bring augmented reality into it. We brought augmented reality into kitting areas in Russia as well, many, many years ago. We're not there anymore, but we did have augmented reality that we would pick the part. The operator could look, see what part it was. There was no risk of getting the wrong part. We brought in the design reviews and digital prototyping. This then gets us away from cutting steel unnecessarily. That saves us the transport. If we have a rack built in the UK that's destined for Spain, it's in Spain before we know it's wrong. We then have to start fixing things. You know? And this takes away all of that side of things. And we use it in the plants for training. Excuse me. So it's not specifically part of the business that I do, but the plants are using the virtual world to train. So they will have the operators connect connectors, make sure they can get inside the engine compartment of the car to be able to read something, you know, to sit down if they need a happy seat to be able to do it. All these things are all the bits that we are starting to see from using the virtual world and the benefits that we're gaining from doing these reviews, doing them online as we've had to do for the last 18 months, stuff that previously we had to go in the plants for, now we don't. Next one, please. So we looked at how to use the technology, what the financial impact of it all is, and our end assessment realistically is that the financial impact is minimal to us. Yes, we have an outlay of a license. Yes, we have an annual maintenance cost, but the money that we are identifying we're saving through not doing things 2 and 3 times offsets that completely for that. The bits where we have to make sure we're able to keep to that is that we have to get the other departments we work with to make sure their information is up to date, because it's like any system that we work with, it's as good as the stuff you put into it. And that's the key bit for us, is making sure it's up to date and it's there. And the key bit that's come to a fore, as I said earlier, in the last sort of 20 months, is the virtual world has reduced our need to be on site. And we've been able to do reviews with our site representatives without traveling to the site to do that. We've been able to say, let's look at this, how's that work? And that's not been a choice thing, that has been a must have because of the world and the situation that we found ourselves in. And with that, that's driven a change to our business going forward now. Our business will change from the MFB side, that we no longer, I need to go and look at this. It's what's it in the virtual world. Why can't we look at it in the virtual world? That's the first challenge now to anything. Why can't we look at it in the virtual world? Why do we physically need to go there? What do we need to update? So the next few slides we'll walk through are just a few samples of the work that we've done to get people a feel. So this is the part that we've taken, that we've modelled of Valencia plant. And these are screenshots that are driven within the VisRender system. This is not a screen capture that we've done through Windows Screen Snip. This is done purely through the VisRender screen capture tool that's within it. So this shows the trim and final hall in Valencia at a distance. And again, even though there's a lot of content in this model, we can still walk around on a normal laptop. We don't need to have any advanced computers. So, sorry, we go back to the next one, Dimitri. I've finished on that one.
Absolutely, yes. Go ahead.
And this is some of the work that we did as a design review up front. So we've installed here, this is looking at what we created in the virtual world for some kitting areas. And these are actually associated to engine and transmissions. So we have to kit parts for our engines and transmissions in Valencia, because we have across the Mondeo, the S-Max, the Galaxy, the Transit Connect and the Cougar, we have 71 different engine transmission combinations that we can produce. Yeah. And to do that and get them ready for the car, we have to have different kitted areas. We can't fit all those parts on the line side. The engine dress line is a 3-meter station. Normally we have 5 to 7 in an assembly hall. So this is what we generated. This is what we walked through with the local team and said, you know, this is what the kitting area needs to look like. This will meet the ergo requirements. We've locked ourselves at the right floor height. We've had a walk round. Guys, let's take some feedback. And if we go to the next slide, then we can look in a different area of the plant as well. And this was all worked through with them as well. And we've seen here that this is the instrument panel production for the new Cougar on the left, you can see. And with this, we have an operator workspace of 0.8 meters. We can see clearly walking down there, that 0.8 meters is a very tight space for our operators to work in within there. We can see that easily. We can see them turning to get to those parts is difficult. Unfortunately, space doesn't allow us to make it any better, but we can see any issues that we're going to have up front and any conversations we're going to have with our union partners. We've got a heads up that they're likely to come. We're not going to get caught by surprise with them. We can also make sure that we meet any of the local legislation through doing it this way as well within it. On the right, we have in the main hall again, we've included some of our delivery equipment. One of the things that I like within the system is if we wanted to, we could set an automation on that truck and we could have that truck run up and down that aisleway at the frequency that it would run in real life. We could set that speed going. So one of the things that we struggle to talk to some of our seniors around is understanding the complexity of things and the speed that things run at. At full volume, this plant that we're looking at is capable of producing a finished vehicle off the end of the production line every 35 seconds. To do that, you need a lot of material flow to support that. And these aislways are never still. And we will get questions like, well, why don't you do that? Put that there, he can park that there. So by representing the traffic flow through the movements that are enabled through his render, we can show exactly why you can't put that there, because he's not got enough time to get up, pick the part, put it in the line side, get the old box, get back on the truck and move it before someone's hit the back of it. And we can show that. Now, we can show that easily with that. And then, as we said earlier, if we move on, Dimitri, please, we can look at using VR.
Stuart, sorry to interrupt, but how often do you do these reviews? Because I mean, these look. I mean, you say you're using all the latest data. How often are you running these things? Is it daily? Is it weekly?
So for us, our function is a launch function. So we are solely concerned with installing models into plants and getting them running. And then our responsibility hands over to the local production plant 90 days after what we call the job 1 day, which is the production vehicles off the line that go to the general public. So we're responsible for the next 90 days, and then it hands over as an operational concern for that. So every time there's a launch, we would do this process. We would update the CAD of the kitting areas, the line side, and then we would review through. So we would have a process called the cycle line layout, which is where the parts are allocated to the stations on the line. We would then validate that, and there can be hundreds and hundreds of stations in the plant. In the Valencia plant is a twin system, so that means it's got just talking trim and final now. It has a twin door line, twin trim line, twin chassis line, and then it goes into a single decking, and then it goes into a twin final line as well. So that lines means there's stations each side, and there's sort of 3 on each system. So you have trim A, trim B, final A, final B, and there'll be A1, A2, A3. So there's probably near 1,000 stations within that environment that we would, in an ideal world, model and buy off in the VR environment. And that would be done on each launch. So we would aim, in an ideal world, that we would have this model ready just after program approval. And then we spend the time working through the reviews with the plants to get the station how it should be before the installation is done. And then the installations are normally done during a shutdown changeover period around it as well.
Absolutely.
So, excuse me, by using the VR, we're showing that we can reduce the launch cost, because by reducing the physical presence in the plant, that all gets costed against the launch of the vehicle. And ultimately, that launch cost goes on to our calculations for how profitable our vehicles are. We get the understanding very clearly for people that aren't so competent and confident reading drawings. They can clearly see it's like them holding the phone in their hand rather than looking at a picture of it. They're holding it in their hand, and that's the benefit that we get from them there. It helps us look to what we can eliminate which adds cost to us. So anything that doesn't go directly into the line side adds cost to our business. We can look at how we move things around to get the best fit line side, to get the most parts line side. We've spoken lots about this, about eliminating changes driven by the lack of understanding. And we've looked at how we lead up, how we can speed up our launch process. We're getting the risks earlier, we're getting issues earlier. By getting them earlier, we can fix them earlier. Therefore, we're not running into delaying bigger parts of the launch. It allows us to plan more accurately. We're not, if we've got the virtual world and the layout signed off, we're not reliant on last minute suppliers and paying premium prices, because we can book the work in highly in advance when it's needed and get the best rates for the suppliers doing it. And we said reducing the travel. You know, we're estimating we can reduce engineer visits by 30% by working up front in the digital world.
Yeah.
That draws us to the end. I've got no idea, gents, if that was 15 minutes or well over. But thanks very much to the audience for taking the time and listening. Thank you.
Fantastic, Stuart.
That was great.
So I
Thanks
suggest
very much,
also
Stuart.
looking at the time. Yeah, John, do you have any? I mean, I would recommend we move forward. With
Yeah, I think we should move forward, but that was brilliant, Stuart. Thank you.
couple
Really
of
useful.
questions. Fantastic. Yes. So next up, I think now we're going to dive a bit deeper with Paul. Paul, there you are. Welcome. How are you doing today, man?
Good, thank you. Thank you, Dimitri.
Excellent. Yeah, so I think you have the ability to share your screen, but I would like to introduce you as well, just briefly for those of us who don't know you. So you bring in 17 years of VR experience, and I think you were with Virtalis for almost 15 years, 15 and then
right.
I mean, we're looking forward to your presentation because listening to you and bringing your input on how you support customers in designing systems, delivering systems. I mean, it's always a very exciting thing to see, to get demoed, and it's always, yeah, interesting to see the newest of the newest. So let's start and share with us, because I mean, I think we're now getting more practical. So share with us how enterprises can use or are using VR in their design review process. So let us see how this works in reality, Paul, how it can work in reality, and show us around.
Hopefully you can see my shared screen.
Yes, we can.
Excellent, excellent. Right, so thank you, Dimitri. Thank you for the introduction. Yes, I work in a role of helping clients decide what the right solution is for their visualization. And one of the things I want to show you is just a bit of a story about how you might implement VR in a business. And to do that, I'm going to use VR to show you the story of VR. So we're going to take the case of a fictional factory. This one happens to make wind turbines. I just want to point out here, I'd like to thank Vestas for the use of their data in some parts of this model. I'll point out that this isn't a model of their factory or all of their processes, but we've utilized their data to help it come alive. So let's take the example of a client that wants to build a new product. Let's say they've got a really demanding schedule. They want to implement the latest technologies as fast as possible. They want to ensure that they've got a marketing leading solution. They want to keep their cost of development down and keep that cost down throughout the life cycle of the product. And best way to do this is to develop a really strong digital thread. We could say that a digital thread is effectively a digital twin that uses one set of data from the concept all the way through to its end of life, through past its commissioning to the end of life of the product. So let's take this one step at a time. Our designer, as Stuart has quite really well pointed out, our designer develops nice, detailed, complex CAD models. And they'll do some reviews of that data on their 2D screen at their desk. He wants to take that a step further. He'll go and put a headset on and review that in 3D. And reviewing it in 3D will bring out a lot of issues that he may not have spotted in the 2D world. Putting you in that 3D world gives you that spatial awareness. He may also decide to share those models remotely using a cloud or web-based platform, something like Virtalis Reach does, and share those to people on other devices like mobile phones or tablet PCs or other headsets. But what's the next step? The next step could be to do this on a larger scale. So here, a lot of our customers have VR suites. This is a fairly small suite, so we've got 7 seats in it and a large screen. This screen allows you to bring VR data in and view that at a one-to-one scale. In this case, we've actually got a rear projected VR system. Rear projected because we don't want to cast a shadow on the screen using a projector if we're standing right up close and interacting with our data. In this VR suite, we have a number of advantages. We can see the data at one-to-one scale. We can be in the data, walking around it and looking at it, and we can communicate with a group of people. They can see what I'm doing, and I can see their reactions to what I'm doing. This face-to-face experience has a huge amount of value, and we're not encumbered by cables like you might have on some HMDs, or that isolated experience that you get in some HMDs. It's not to say HMDs are not extremely valuable because they are, but this is a way that many enterprises get to look at their data, and we've installed these in practically every solution you can imagine. So right. How do we do that? Well, we can import some data. Here we're going to import some step data. So this is actually running in our software visionary render. It goes off, picks the data up, and here it is. So in a VR suite, you would see this piece of data, this product that you're going to query, review, sits almost holographically in front of the screen. And using my body, I can walk around it, I can duck down underneath it, I can look down on top of it. I can also use my hands to reach out and take it apart. So we can interact with the data and investigate it to a much greater level than I could any other way. And by the way, I'm streaming this from my laptop. I'm doing this live off my laptop right now through our software, which means you can interact really naturally. The other great thing about these systems is this one happens to be running our software visionary render. That's fully collaborative too. So we can connect multiple VR systems together, and you can bring in people not just in the same factory or in the same country, but across continents. You can connect those together and work collaboratively in that way. So that's how you do the basic design review of a part.
Mm-hmm. And Paul, can you also show us how this can be part of more of a larger assembly and how this fits in the bigger picture?
Yeah, that's great. A great question, because essentially this is a part we're showing. Now, any big complex product, let's go and have a look at one. So if we jump into a finished nacelle, so here we are. So our wind turbine is now a complete CAD model. So this is the Vestas data set, and we can see the complete finished nacelle. By the way, the nacelle is the box that sits on top of the pylon, and it contains a huge number of parts. It's a very dense environment for parts, and it's really important they are positioned correctly and efficiently. And we can see every little detail. So I can go down to nut and bolt level. I can look at the individual washers. I can take things apart however I like. We can go inside it and get a closer look at the data. So if we go inside here, what we were saying is these parts can now be assembled, these individual parts that you've approved, and put together as a larger model. And these models, these pieces of equipment, are often made up with products that come from a number of different suppliers. So as an example, this generator could come from one supplier and come from a, let's say, a CATIA data set. This gearbox here could come from a SolidWorks data set. The rest of it could be out of PTC's Creo, for example, or Inventor, or Teams out of Siemens NX. So you can mix all of these data sets together in one place. And then with those different data sets and different file types, you can actually grab hold of them and use your hands and move them around in the scene. You could work out whether that would fit in there or whether you've got a collision. You can see the colors changing as I'm colliding with parts. So you could do fit and test and access tests. In a fully tracked world, in a VR suite, we can even track real tools. So you could stand in front of that screen and use real spanners, real hammers, real drills to maneuver these parts. So this is really where it all comes alive. This is where engineers and marketers and customers can visually review all of their data in one place. And importantly, and Stuart picked up on this, they all talk the same visual language. They've got a virtual prototype that appears real at one-to-one scale, which they can manipulate.
Right. And Paul, how can we take this further? I mean, the next steps into, I mean, the next step is to build it, isn't it? I mean, can you show, because I know we have an end-to-end process which transfers data models throughout this whole product development supply chain. So can you just show us some of that flavors and how it works, you know, taking it to the next step that you
absolutely
preparing for production.
So this ties in again very nicely with what Stuart said. So if we go down onto the factory planning session, we can actually take those CAD models and use them in a discrete event simulator. Here, we're actually running a video, but this can be connected directly to your VR environment. This is Lana's Witness, and that can be connected to VR, and you can use your data to plan exactly how a factory is going to be laid out. Make sure that it's efficient, that it's flexible, that it's optimized for the product that you're beginning to design right now. That works really well if you've got a building that you've got a CAD model of. But in this case, here's a model of my building. But imagine that this is an old building, one where CAD doesn't exist, and I've got to lay my factory out in here. Well, I can actually mix data types, not just CAD data types, but I can start to mix things like point clouds. So we could scan the factory. So here we see the point cloud being built up. And now I have a point cloud model of my factory, which doesn't have a CAD data set, and I can still maneuver around it. I can go and look at that data in real time. I can mix this with my CAD model. So you can see here we have a CAD model of the building mixed with the point cloud data of the building. So we can check whether things are really accurate. It's a really powerful tool in that respect, that we can mix all of these data types. So let's just empty that. So once we've got that factory and we've come up with a layout, we could say, well, what does the production line actually look like? So here we've taken that factory scan model and we've put the factory in that plan, and we can animate it so that we can see what's happening and how all of the different parts work together, how the different machines can work together. We could even be really smarter than that and start to connect these virtual machines to the real machines and see what happens when one machine stops. You see the parts stopping in the line. We can go down to the position of this person, see what effect that would have on the rest of the line from his point of view. This virtual world adds so much value. Furthermore, we can add other bits of data in. Statistical information, like quality information, could be quite dry to look at, presented in Excel sheets or in spreadsheets of one sort or another. Well, how about looking at it visually? Here, we're looking at the coating thickness on a turbine blade. So instead of looking at it as a spreadsheet, we can see it actually laid out physically on the turbine blade, and we can see all of the points where it fits within tolerance and exactly where it doesn't fit within tolerance. You can lay out these things and see data in a visual way, which adds a huge amount of power to what you're doing.
Yes.
And finally, on the factory floor here, we've actually got the full nacelle, and we could actually build this up in the virtual world part by part and practice the assembly process and optimize that assembly process. We could work out how our work cells are laid out and in what order, and optimize that all well before, and again, I'm sorry to keep coming back to you, Stuart, you use this phrase, well before any steel is ever cut, any part is ever bought. This is done right at the beginning. So just to wrap up, this is really where engineers, marketers, customers, manufacturers can all get together and talk the same visual language. There's so much more you can do in this environment. It's such flexible. When you get this digital thread in your hands, it can add so much value to your process. If you want to know more, please talk to me. I hope that gives you a good example of what we're doing.
Fantastic, Paul. Thanks a lot. So anyone interested in learning more and also about how this data, this example, also translates into maintenance functions, monitoring, quality, then let us know, because we're going to move to the next session. And let me dive directly into that. So we recorded a video. We had the opportunity to record a video with John Martin last week. And John is a VR shipbuilding pioneer. He brought VR into BAE decades ago. In his work, he had to convince many people, many levels, and eventually helped them save a lot of time and a lot of money. And basically moving from expensive prototypes to digital models. It takes 70 years to build a submarine. John got awarded some prestigious engineering fellow status within because of his BAE work. And I'm going to start a video of him. It's about 5 minutes, where he takes us into to his world. What are the prerequisites and how XR is used in this shipyard world, from concept to testing and commissioning. So let me open this over here and show the video.
Thank you, Dimitri. First, let me explain. Why do we need design models? Well, historically, the design master was drawings, and the chief draftsman, the section leaders, and/or managers could walk through the drawing office, look over the shoulder of the designer at the drawings, and instantly have a view of the progress of the design. In a modern shipyard, the design master is a CAD 3D model and its underlying database. But CAD models need skill and training to operate and view effectively. And due to the complexity, they are not very efficient for fly-through visualization. A quick, simple, and effective means to look at the design by non-CAD trained staff, such as design supervisors and managers, through XR tools and processes. These can be expanded across the whole shipyard. So how do we make XR efficiently? Well, the visualization model is a simplified representation of a CAD geometry, and it allows fast and effective fly-through viewing, and it improves the accessibility of the design review throughout the shipyard. To take full advantage of this capability, the implementation of a visualization system, such as Virtalis' visionary render solution, must offer the following. We need fast, simple, accurate data conversion, intuitive conversion by non-CAD trained operators of a selected volume of the CAD model, such as a compartment or a volume bounded by frames and decks, is essential for productive use of the system. We also need ease of use. Operating the visualization tools must be easy so that non-CAD trained operators can start the system, load the model, choose the viewing point, and fly through, remove, add components for clarity, and access the underlying technical data. The system must be driven by the user. Any user who can benefit from viewing the virtual model must be trained to log on, load the data, and operate the system at any time. We also need a spectrum of viewing technologies. Personal devices, such as laptops, desktops, tablets, and mobiles, can increase the productivity of viewing the CAD model. It offers an effective means of discussing issues and problems in the design with a colleague. Planners, project managers, production operators can also look at the specific areas of the model on their personal device at any time. Meeting rooms with medium-sized stereo projection displays can be used for small group discussions on the design. They're very useful for team meetings when they're resolving clashes, for example, or they're deciding on some particular access or problem. Large screen stereo projected rooms are used for large groups, used particularly for design reviews, for acceptance and customer approval and sign-off. Specialist tools, such as immersive headsets and mannequins, are used in selected cases and enhance the review process considerably. And of course, the visualization model under release control must be available across the whole organization. So how is XR used in the shipyard? Draftsmen and review teams progressing the CAD model typically use a visualization system to increase productivity when conducting fly-through assessments or reviewing a particular aspect of the design. Although very successful, there is a common misconception that this is the only effective use of a visualization system. Visualization of the virtual model is beneficial throughout the full ship product lifecycle, and now I'll explain how. The first stage of the lifecycle concept design, we can use visualization to analyze the viable design options against their operational requirements using 3D geometric models from the concept design tool. Stage 1, the functional design. As the design matures, the general arrangement layout of the ship will be evolving and can be reviewed, agreed, and signed off by the customer during XR viewing. Stage 2 is the detailed design and spatial integration. This is a major stage for the application of VR technology. Draftsmen and designers use a visualization tool to quickly fly through to review the CAD model regularly. Groups use meeting rooms or very large screen specialist VR rooms with a wall system or cave to review the CAD model maturity as the design progresses. Stereo projection of the models during reviews is a major benefit when discussing topics such as crew accessibility, safety, operability, and maintainability. Stage 3 is outputs for production. Using XR to view the design model has a considerable improvement on the understanding of the design to non-CAD engineers and production teams. Simple simulations showing the sequence of fabrication, outfitting, or equipment removal are a very useful guide to these production teams. Stage 4 is manufacturing. The use of visualization systems for planning is a significant contribution to successful manufacturing and build, with access to the design layout from the early stage. Planners can advise on the design areas to suit the build strategy and view the model to determine manufacturing and installation sequences. Stage 5 of the process is assembly, install, and outfit. The visualization system can be selectively viewed to show the assembly sequences and install procedures defined in planning. Lifting and turning of units, moving large blocks, shipping large complex equipment can all be simulated in the VR system to help select and verify the methods to be used. Stage 6 is test and commission. This is not a stage in which virtual models are regularly used, but the option to use augmented reality to identify controls such as valves, instruments, and test points in a system would enhance and simplify test procedures, minimizing the need for drones. Stage 7 of the process is in service. There's considerable talk about the use of digital twins on the ship in service based on CAD models. However, CAD needs highly skilled operators and a set of standards and procedures to be effective. Ship owners do not have these skills, or the funding, or the resources, or the standards and procedures to support such CAD models. A visualization model in the simplest polygon form is more likely to be sustainable for the life of the ship and can be operated by any of the crew with minimum skill or training. So how can we organize for effective XR? In my opinion, it's a fatal flaw that many XR implementations have a specialist virtual reality department who own the technology and exclusively operate it, load it, and drive the virtual model. The role of a VR specialist team should be to train, advise, update on development capability, and support the system. To be truly productive, the system must be easy to use in order that any member of staff, with minimum training, that needs to see the model can select, load, and review the virtual model at any time. The objective must be to have the XR system as a day-to-day tool, such as Word and Excel, without the need for specialist operators who need to be asked every time you need to view a model. Thank you for having me, Dimitri and Virtalis. If you have any questions or points that need clarification, please feel free to email me.
I should say thanks to John. So we received a lot of questions also on this particular session. So keep on coming with them. So regarding looking at the time, we're going to move to one of the demos over here. John, can you introduce it when I'm launching it?
Sure, yeah, it's got some sound, but basically what we're going to show is a very quick demonstration of XR-powered design review using Virtalis Reach, our new cloud-based collaborative platform. So what we're going to see is
following the input for the cold water, we're coming in from this part, and this is the new section here, is it?
Yes, this is the part we're expecting from our partner.
When are we getting the CAD for that?
Should be next week.
Right, okay. And are these pipes correct now for that new part, or is that for the old part?
No, that's for the new part, so this piping's all correct.
Right, okay, because we're missing an alignment here, aren't we? We're coming in too high.
Oh, yeah, we are. Those two flanges don't line up correctly.
Who designed the pipes? Can we get them in to
Yeah, so that was
discuss?
Dave,
Can we adjust these to fit with the chiller?
Hopefully, I'll just invite Dave to see if he knows.
Hey Chris, hey Tim, how's it going?
Hi Dave.
Hello. So, question is, with the new pipe fitting coming in here, and these new pipes, we're coming in high on the chiller. Can we drop these pipes back, or will the new part, is that the reason we raised them up?
That is the reason why. The only issue is we had to do that because if we change the height of everything else, it'll be quite a lot of work to move all the pipework in the rest of the system down, even if it's just a couple of inches. Do you know if it's possible to raise the chiller at all?
I don't offhand, Chris, do you know?
I don't, but let me see if Andy is available and bring him in. So send him a link. See if he joins.
Hello Chris, you after me?
Hi Andy. Yeah, we just got a bit of an issue with the alignment of the pipes to the chiller that you designed. Tim, do you want to explain it for him?
Yeah, so we've got the new part where the intersection comes in. As the pipe comes in, we're coming in high on the chiller here and on the return. So can we raise the chiller up to fit that? Because otherwise it's looking like we're going to have to do a lot of work on the pipes.
So here and through there, yeah. I should think so. Let me run some analysis. I'll get the results in the next couple of days and get them to you. But I think that should be okay. Is that all right?
Yep, no, that sounds fine to me.
Great.
Thanks, guys.
Thanks, guys.
Cheers,
all. See you again soon.
okay. So what we've just seen there is a really quick example of XR powered design review using our Virtalis Reach product. And what basically that showed you is how we can do really quick dynamic ad hoc collaboration in a distributed environment, do the kind of design reviews we need to do, and come to some quick solutions within a few minutes, effectively. So I'm gonna have to basically skip through some of these slides quite quickly, simply because I think we're kind of looking at the time. So I mean, really, the main point here is that we can effectively enhance design reviews significantly using this XR powered design review approach. It allows us to augment the model and add a lot more value to that model, as many of our speakers just previously have said, as Paul highlighted, as Stuart highlighted earlier. We're able to add features and functions and behaviors to the model. We're able to do inquiries on the model in terms of understanding the fit and the clashing and where parts need to be remodeled for packaging and integration issues. So we can effectively breathe life into this flat 3D model and bring it to life as you would with a physical model. You can interact with it, you can touch it, you can make a lot of decisions using this. And this is the real power behind the XR powered review. If we look at some and just summarize some of these benefits, so we quickly establish a top-down common vision for large complex models consisting of tens and hundreds of thousands of parts. We can undertake design reviews of life-size models and mock-ups in multidisciplinary teams. We can create compelling virtual prototypes with minimal data prep time, supporting regular iterations and using live data directly from many, many different sources, as Paul showed. We can easily incorporate metadata and behaviors and improve much of the communication that goes on between the suppliers and the different departments. And we can easily share those prototypes, as you saw in the last demonstration, through collaborative platforms to involve remote teams. So this is the real power of the VR enhanced design review. We've already seen some examples. If you just move to the next slide, Dimitri, very quickly. We already have many examples of how this delivers real return on investment as well. Not just kind of showing a technology improvement, but in terms of delivering real cost and, most importantly, time savings. So some examples, just to pick a couple of examples from our customer base. Case New Holland, for example, have reduced concept times by 2 years and overall delivery times by 25%. These are significant amounts of time. And Rolls-Royce have saved nearly 2 million in costs just on a single project by identifying critical issues early in the process, reducing time and consuming iterations and getting things right first time. So you can see the enormous benefits. And I think with that, I think we could probably finish what we're saying in terms of the main slide set. Let's move on now to the panel. Dimitri, do you want to quickly introduce everything, and I'll then take it.
Yes, it would be a pleasure. So, Jim, I hope you are there as well. I don't know if you are. If you are, would be great
Maybe
to.
If everyone could switch their cameras on now.
Yeah, and let me do a brief introduction, because
Okay.
Jim Shaw, mechanical engineer, and before he joined Bentley, where he worked for 20 years in various roles, he worked at Rover Group in the creation of vehicle concepts, and I think he was involved, and I wrote a couple of them down, from Mini to Range Rover, from NG to Defender, and also worked on the BMW group on a number of project headquarters in Munich. So a lot of very interesting insights. And Jim established his own company in 2019, and to bring his passion and experience to a wider group of clients. Jim, also good to having you here. So we have Stuart over there. You are. Very good evening to you.
Hi. Good evening. Sorry, it took me a while. I'm not too used to go to webinar. I've become a bit brainwashed in Teams of late, so apologies.
Man, you made it. You made it.
You made it. That's great. Good to see you, Jim.
Yes.
So, okay, thanks, Dimitri. Yeah, I think I'll take it from here. But basically, yeah, thank you for everyone on the panelists enjoying this, and particularly Jim, who's joining us quite late at night, joining us from I think Saudi Arabia at the moment. I think you're there. So I've known Jim for many years. I've known him since he worked at Bentley as head of concepts, working across all of the different brands there, Audi, Bugatti, Porsche, and he's always been a strong champion for introducing innovation and technology. And I met him while he was introducing bring advanced 3D visualization of VR into the concept design review process at Bentley as well over 10 years ago. So a great deal of experience, and thank you for joining the panel, Jim. So what I think we'd like to do first of all is we do have some interesting questions we'd like to put out to the audience, but we'll do that towards the end. At the moment, we have two interesting topics that we'd like to discuss on the panel, really. Two main topics, which are, firstly, I'd like to look at the question of where we think XR design reviews or XR powered, VR, AR powered design reviews will be shaping the future of product development process. Particularly, I'm interested to know what various people's thoughts are on this. Obviously, you guys have got a lot of experience, all three of you, Paul, Stuart, Jim, you've all got a huge amount of experience from different areas. And I'm interested to see, obviously you know where it is right now, but I'm interested to understand your thoughts on where you think it's going. So maybe, Stuart, do you want to kick us off in what you think is coming up next for you and how it's going to shape the development and process at Ford?
Yeah, sure. I mean, I think for our perspective in Ford is as material flow, we're one small element of the launch team. And I think the real bit that's the challenge and the drive that's going to make things better is getting the wider community of these launch teams involved, getting the value of it sold to people. I think at the moment, there's still within Ford a bit of a concept of potentially VR as a toy. People see it for the training. They see how we can do that. I think we're effectively pioneering factory layouts throughout the Ford way of doing things, of saying, this is how we should do these things. We should do it like this first. We should get everything done. And I think that that's the challenges at the moment for us of dragging people into that party to make sure that they understand that there's a benefit to this. We're not doing it because it's like a toy. It's not like we're playing games every day with VR. We're doing it because there's a business benefit to doing this. And I think that as we do that, that will then drive the development processes for us. It will bring in people. Suddenly the penny will drop and they will say, actually, hang on, we could do that 6 months earlier and we could see then whether it's going to work or not. And I think that's really the key bit for where we need to drive it in Ford now, within our areas, within our manufacturing. As I say, the actually having a product, having an engine, having a robot cell, that sort of thing's there. But it's getting the more archaic engineers, shall we call them, the older school engineers, getting them to understand the benefit. It's not a toy. It's a very good business process. How do we drive it forward with them? How do we get them bringing it into the table, coming to the real world? We still daily, we encounter, oh, I'll just go down to the shop floor and look at it. So, but you're 800 miles away. You can't do that anymore. You have to go and you have to start embracing these things. And I think really that's how we need to drive the process forward and develop it more, is to get the wider understanding within the launch communities. And for us, that launch community spreads from the UK, Germany, Spain, down into Romania and out into Turkey. And it's building that bridge of Valencia is our stepping board to say, this is how we're doing it here.
So you don't see technology as a barrier to this, or there's no hurdles in terms of technology. It's more about disseminating the business case, making it effective, and convincing, if you like, the old guard of the benefits and moving them forward in that process.
I think back to when we started this journey about 4 years ago. I think we started doing this, and I remember there was one of the engineers sent a message out: when you've all finished playing with that toy, can we get on and do some real work? And that stuck with me. That stuck with me. Personally, I think I count myself as I'm an early adopter of technology. That's my personality, my mindset. Other people not so. We have a senior engineer who is lightheartedly called the dinosaur because he is so archaic in his adoption of technology. With that, and it's bringing those people to the table, and us as leaders of this world, bringing people with us to say, look, here's the benefit. This is what we're going to gain from it. And taking the appreciation at the same time that benefit to us as leaders is actually detrimental to them, because some companies still pay people for traveling. And if we're removing the amount of travel they need to do, there's no incentive for them to embrace staying at home and doing it on a screen. And that's the important thing, I think, is the mindset change. And the technology's there. I think the technology moving into the reach products and and the reviewing over the webs, that's where we need to be going to with it. And
it's
getting
interesting
people to adopt it.
It's interesting you put these things out, because quite a few of the questions that are coming in from the audience are related to that subject of how do you transfer people from the old world into this new world of thinking, because the benefits are all quite clear. And this is where I'd like to sort of introduce Jim as well, because you've been on that journey, didn't you, I guess, to some extent in Bentley, in trying to carry not just Bentley, but the whole VW group with you in that journey. And I'm interested to know what your thoughts are in terms of how you went through that journey and where you think it should go next.
I think it took some visionary use cases. You only had to get the right people in the right technology once, and they were sold. All of the benefits you've been talking about today are real and apparent. You just have to have the right use cases to bring the decision makers to the same point of view. I think the technology exponentially improves year on year. The usage has exponentially increased. The pandemic has only accelerated that situation. I'm glad to see that my old colleagues fared well in the pandemic, because they were already established with good distributed virtual review processes and techniques. I think what will change going forwards, and again, if you think about the pandemic, hybrid working is becoming more and more of a reality. Yeah. Stuart's been mentioning, you can be anywhere and engaged as long as you're awake, of course. Being in China and working with North America may be a bit of a challenge, but you can have distributed workforces now. So you can start to access the best talent into your projects without actually owning the overhead. And I think this is going to be the big change on the future product development process, that experts give you 2 review hours per week, and you really benefit from that, and they get a complexity of work which improves their subject matter expert opinion. And so the ecosystem changes from something which is vertically integrated to something which is a collaborated network.
Absolutely, and I think that's a really good observation, because I remember when we were working together several years ago, even back then, you were emphasizing this time constraint with the experts, and you were saying that if we could get the expert to see what we want them to see and sign it off, even when they're on the plane or in the airport or wherever they are, to be able to join us in this virtual review, then it would save a huge amount of time, because you wouldn't have to then go through 10 or 15 different iterations. You get the right people in to do the right job at the right time. I think this is where the real power of this technology, having it digital, allows you to share this digitally, which means you can engage people. And I think one of the areas I think we were talking about earlier was about, it's not just about getting people together at the right time, right place more easily. It's also about having that visual platform that means you've got that common understanding and common vision, because bringing multiple disciplines together with different terminology and language is always a challenge. I know from previous existence, it's difficult when you've got designers talking to engineers, talking to manufacturing, and you're all talking a different language effectively. But having that visual virtual prototype, having that model that you can touch, and interact with, it's a common language. I think, Paul, you touched on this as part of your presentation and demo earlier about having that common language. I mean, if I can bring you in at this stage, Paul, I mean, where do you see this going? I mean, we've talked a lot about the collaborative side of this, which is all now becoming possible, but there's also still, COVID still exists, but it's also slowly starting to reduce a little bit. So we are starting to come back together again. And there is this, I don't know where you see things going in terms of additional technologies, some of these big kind of facilities that people kind of stopped using during COVID, but are starting to slowly come back to, I think, from what we've seen. And maybe you could talk a little bit about where you see that going.
Absolutely. It's about accessibility to the data. I mean, we've got data's valuable, and there's a lot of it. If we can put it into a place and make it accessible to people, that gives you a great deal of value. So whether that's in a headset or on an AR device on the factory floor or out in the field or in the airport lounge on your mobile phone, those are all valuable things. But we are seeing people still utilizing their large scale systems, doing group reviews. They're still being put in these systems, and the technology for those is changing. One of the things is typically with an immersive wall, it's always been restricted to a single person that's been immersive. Now we can do 3 or even 6 people all looking at the same wall at the same time, seeing their own individual views. There's a great step forward in those technologies. And if you don't have space, we talked about rear projection, that takes up a lot of space, but now we're getting the introduction of LED technologies. And those are hyper thin. It's like putting a television on your wall, and you can run those in stereo as well. And that saves a lot of space, and it becomes a very valuable and flexible tool in that way. So the technologies are moving fast. It's a really interesting, exciting place.
Yeah, I think this is something that Jim just said. I mean, the technology is moving exponentially in all directions at the moment. So I think actually we're going to touch on some of that at our next webinar, in the systems webinar that we're going to be doing in a month's time. And maybe that's something people can lock into and check out, because we'll be talking, I think we'll be deep diving some of these technologies going forward. But I think maybe I'd like to maybe come back to Jim. I mean, coming back to this issue of the common visual language, I mean, do you see how potentially this technology is going to change processes going forward? Do you think it's going to do you think there's going to be any fundamental changes to the product development process as a result of this, or do you think it's more that we're just going to work faster, smarter, or is it actually going to fundamentally change the way we work in terms of the distributed organization and not having such centralized big OEMs, if you like, and maybe more distributed supply chain and things like that? Do you see any major changes happening because of this?
I certainly see a more distributed work effort. It still requires coordination through milestones, but I think the whole process probably becomes more agile as you break down the conflicts you try and resolve. One of the things I drove forwards was to try and prioritize the issues with the biggest impact. So we were working on the hardest issues first, and we'd come around to those which were less difficult to crack later. There's also the technology. I think 5G is also going to help people, you know, in their reviews to be more accessible. I'm a fan of just about, you know, anything, a power wall, a cave, a headset, doesn't matter to me, as long as I can be in a visual sense discussing something. I don't really need to understand every manufacturing term or every materials term, but because I'm having that one-to-one, I'm taking away some of my misunderstandings and ignorances much more quickly. And I'm I'm not a fan of PowerPoint engineering and sitting through long committee meetings where long since has the meaning of the presentation gone, and people are trying to make a decision on a few slides. You know, for me, experts should be bringing their opinions through this visual medium into the discussion point, such that you can make the right decisions on the right facts. And I think, you know, working in data, not on anecdote, is certainly the way forward. So that distribution of expertise only empowers you to make better decisions faster.
Yeah, I think that's a really good point. I mean, in terms of coming back to this issue of moving it forward and getting people to really understand what it's all about. I mean, Stuart, you mentioned that that's one of the biggest areas that you have to kind of focus on to try and get buy-in across the organization. Do you think that this the virtual model, the XR powered design review, sells itself in some ways? Do you think, as Jim said, maybe if you get the right people in at the right time, that it sells itself? Do you find that when you're talking to people, or do you think it needs more than that at this stage.
No, I think Jim's got it right. It's having the right people in. You know, we have people that in our world we have to get their buy-in, but they're not interested because it's just one more thing they have to do. So they're not the right people to get this driven forward. We need the people that are the right people, that are the ones that are interested in it, to drive it forward as well. Because without that drive, they're not going to spread the message in to the plants. They say, do you know what? We went to this BIOS session and it was such great value. We didn't just look at a PowerPoint, 3 slides, and got bored, struggled to stay awake. We actually saw what we're going to get. And from that, that's the power of the review doing it, is that they're physically, they're not necessarily immersed in it, because not everyone's going to have the goggles, but you can walk through the 3D set on the screen, you know. And the bit with the goggles is if you want to place something in it and see how it fits, that's where the benefit was. But the rest of it, for the layouts that we looked at, we showed in our presentation on the screen, you know, that's more than enough. And if you get the right people that will immerse themselves in it and say, yeah, that's it, then they'll spread that word to say, do you know what? I sat for an hour of PowerPoints or 5 minutes of that, I understood it completely. Done. Yeah. And I think that's where the driver's going to be for us, trying to get that driven through and that message through, you know.
Yeah.
Getting
I think
it's
that's
the right audience for us to present
right.
to get the traction going.
Another thought, which was demonstrated in Paul's presentation, which is this mixing of different media, and also our pioneering submarine chap. I've forgotten his name, but I probably know some of his old colleagues.
John Martin.
The asset,
John Martin,
really, the asset is really valuable, and its life expectancy should, through an easier solution of review, live much, much longer and be that value all the way through the life cycle of the product or the service, if that's what's being designed.
I totally agree. I think we're seeing this in some of the sectors that we're working, where, as you said, with John Martin and the shipbuilding industry, where some of our clients are now saying, well, we don't just want to build a virtual prototype for design review or for engineering review. We want to build it for life. We want to build it as a digital twin of the product. So in those sort of industries where they're building, say, a ship for the Navy or a submarine for the Navy, they don't just want to hand over a physical ship. They also want to hand over that digital twin of the ship that they've built. That's as much, that's has a lot of value to hand it over to the Navy, so they've got that digital twin for maintenance and for all the other tasks as well. So it becomes, it's not just about design review. That virtual prototype becomes, as you said, Jim, a lifetime. It's a lifelong part of the product, and it now lives with that product and should live with the product through its lifetime as well, and through its retirement as well. So this is a really good point, isn't it? Yeah.
John, give me a thought to add to that as well. One of the key things in our business nowadays is reuse. We don't buy brand new rack fleets every time anymore. What can we reuse? And this forum gives us that world to instantly pick the part from our CAD system, have the rack in our VR system. Does it fit? Doesn't it fit? Yes, no. It's a very quick way of doing that. Currently, we have to wait for our CAD engineers to download a surrogate part. They then have to go in CAD and manipulate it. And this brings the point that John, the submarine, I think it was John, the submarine guy, was saying about, no, it's because he wasn't here. It's a video. His point was about having CAD specialists that could operate the CAD software. And that's where we get stuck there. We can't manipulate that. But in VR, we can we all know how to grab the part and we can put it in the rack. So suddenly we're in a world of what can we reuse and how do we use these design review processes to get that? You know,
absolutely.
We can bring the new stuff in, we can bring the rack in, we can bring the part. Yes, no, it's a very quick decision process then.
Yeah. So getting on what you just said with John, one of the innovative things he did with VR was he had that complete submarine model, but he made it accessible to the guys that were actually building. They put VR suites in cabins bolted to the dock hall wall. And the operators were the fitters, the welders, the wiremen. They went in and they operated the system. If you make the data accessible, it adds value.
Yeah.
And that was really put a lot of value back into the system for them to get the guys involved. It gets buy-in. The stuff is not frightening anymore. The technology is not frightening.
This is comes back to a big area for me in my head in my lifetime of working in this area, and that is, you know, this whole thing should be a layer on top of what we already do with PDM. There shouldn't be any barrier. There shouldn't be a data prep barrier to go from your CAD world into your visualization world. It should be direct. It should be there straight away, ready and instantly available when you need it, as you need it, and up to date at all times. And this is how we make sure that tools like this become ubiquitous and used throughout the product lifecycle and throughout the design chain, that you make it easy to use and no barrier, no simple to just pick up and use, and people will use it. The harder you make it, the more barriers you put in the way of people, the harder it becomes and the less they'll use it. But if you make it easy, they can just log into whatever their PDM system, open up that VR model straight away without having to go through this tedious data preparation process. They're straight in, they can look at it straight away. And having these visualization assets on the cloud sitting on top of the PDM, if you like, gives you that capability to be able to then have that available to everyone and to be shareable and so on. So yeah, I think that's a really good observation. I think I'm just looking at the time. I'm conscious that I don't know, Dimitri, do we want to handle any of the questions? Because we did have some poll questions as well. I don't know if we've got time now to do that. I look to you now to
suggest we do it. Here's the situation. We have a very insightful session, a lot of details.
Okay, yes.
Many of us of the attendees are still here. I
Okay.
mean, why don't we run the poll? Any one of you who need to leave, which makes sense, can happen, leave and follow the rest of the webinar through the video that we'll be sending to you. Those of you who want to stay, because we have a unique opportunity with Stuart here, Jim here. If both of you do have some time with us, let's continue for 10 minutes and run some of the polls and the additional question. That will be fantastic.
Yeah, I mean, if we can run the polls now, and maybe I can pick off a couple of the questions that were picked up. So, for example, Stuart, there was a question came in directed at you about, was there any kickback from Ford? I assume any pushback from Ford generally inside about in terms of making this move towards VR. I mean, we talk about making the case, but was there any resistance to change, and what kind of resistance did you find?
So really quite interestingly, we found that the resistance hasn't come from the seniors and the leadership team. We've earlier this year, we had a short notice session to sit with our manufacturing vice president for Europe. And his question, and he got very similar to the presentation that I gave to the audience earlier. And his come back from the presentation to us was, when can I get this in the rest of my plants?
Right.
And that's been a challenge for us, because we were solely working on it as a team that looked after Valencia, and suddenly we've got teams that look after Romania, Turkey, Germany, and the 2 plants there. And suddenly we're trying to work out how we deliver what he's asking and what he's looking for. How do we get to that now? Suddenly we've got 4 years of experience, and now he wants to spread it across the whole of Europe like that. We hit some resistance with the engineering level, is where we've hit the resistance. Some people, and I think to pick up on your point earlier, John, that one of the key things we look for when we chose VR software is that it should not be additional work. Yeah. It should just be a cap on top that shows us the 3D work. And that was key to us when we chose the software. And it's the engineering level we've hit resistance from. It's not the leadership. The leadership is really well bought into making this way. And it's the standard leadership question of why is it not there already, rather than what's the journey to get it there, sort of thing. But I think fundamentally, the resistance is driven by humans don't like change. No human does. And it's how you manage change in everything that you do. And that's why it's taking us longer than we would like to get this rolled out across the other areas that we're working with, is because we have to get people's mindsets in the right place to be open to accept why this is the right thing to do. Because if we lose that battle, we'll never get any further. Yeah,
I agree. Yeah, that's a good point. I mean, okay, so just come into a second question. I think have we got time for one more, Dimitri?
Yeah, we do.
Yeah. Okay, so we just got one more, which I'd like to kind of and maybe I'll direct this one at yourself, Jim, because I think this is an interesting question, because it might overlap with some of the things you're doing now as well. But in your experience in working, in using VR within, or visualization, if you like, within your organization in Bentley at Concept, did you ever collaborate? Did you ever move to collaborate with suppliers? And if so, how did you involve them in that VR process, in that virtual design review process?
I don't remember doing that.
Okay.
We work with internal partners, but not external in that sense. That was more on a release mechanism in the PDM system.
Yeah. Okay. What about yourself, Stuart? Have you actually involved suppliers in any of the planning, the layout planning that you do?
Yes, really, I suppose would be the right way to word that. Is yeah, we initially a lot of our work was drawn up by a supplier that normally does our layout work. So that's a collaborative partnership working anyway. And we said to them, right, we want you to do this as well. This is the way we're going with it. Give us the bill for some licenses, etc., and let's get on with it. So that was a very partnership thing in getting that supplier in with doing the lineup and the work. And then the phases that we then have to go through is we have to work with the installation suppliers as well, because they're going to install ultimately. This is the design supplier effectively, then we have the installation supplier. So we would work through reviews with them as well. We did it more as, I suppose, stills as much as anything else, rather than pure walking through remotely, because some of the stuff that we needed to do wasn't ready to do that. But that would be our ongoing practice, in all honesty, is depending on which plant we work in, depends on whether it's external companies that do the installations or whether it's internal. And that's generally driven by legislation. In Cologne, we have to offer everything internally first. In Valencia, we don't. So we put it out that way. So that's kind of our process for how we'll move forward now, is that we have the design done. We're working to get the design done in-house now, utilising bringing the DWG in and the drag and drop, get that done in-house. And then we'll sit with the installation supplier. And that gives us the advantage now, is that we don't have to be on site to do that anymore. You know, and I think Jim picked up on the point earlier with the way COVID has changed the way of work.
Yeah.
If you think of us as Ford, we're tied to the southeast of England if we want to work for Ford to make commuting practical. We're not anymore. I now have one of my contract engineers has just moved to Northern Ireland and flies in when we need him on site. And this is the world that this technology gives us. Admittedly, it's got the kickstart by COVID, because it's COVID and working remotely has made it acceptable not to come into the office every day.
Okay.
But now we have the technology, and actually he is the lead guy internally for us that does this work, and he's based out in Northern Ireland. And you know, so it gives us all that drive and the way to do things, and we can work now from Northern Ireland. He can work with a supplier in Spain directly, looking at the items online. So it has given us that advantage, and it has let us work with multiple suppliers now, because we have to have, because of all our interfaces to our systems, we'll have one supplier does one, maybe installs the racks, one supplier installs the cabling and the IT, someone else connects it to the Ford system, just because of the way our rules work. So we can now have that review, and we can do it virtually now, online, and everyone can walk around the installation. If they see a clash, a cable that's going to be in the way or runs a risk of getting snagged, straight away we can pick that up, and we can change it early. We don't wait for the cable to break before we have to do it.
Okay, yeah, good. We've got another question in. This is, I think it's mainly for us actually. So this is a question about, does the Virtalis software integrate with Teamcenter, or do we need to pull the data through and upload it effectively? I think this is coming back to that point about, you know, how seamless is that link to getting the data in and so on. I guess you can explain from your own perspective on how you find it, Stuart. I mean, with the Reach product that we've just launched, the cloud-based system, we have introduced a direct link into Teamcenter. I call it the live link, but basically we can effectively link to data within Teamcenter and then have it automatically updated. So it's not a manual process. It can be set up automatically to refresh as and when the data changes, which does give us that capability to, as I was saying earlier, to give us that ability to have almost like the seamless link. So when you've got your data in Teamcenter, you're updating it, then at the same time you're seeing that live update in the virtual model. So I think that's one of the questions. I think you mentioned earlier, Stuart, that I think you use Teamcenter a lot for all of the data pretty much. So that could help you going forward in terms of extending the deployment. We've talked about that a bit more. We also have a question. Actually, do we have time for another one, or should we look at the results of the poll now to make sure? I'm just worried about the time. That's all. We're nearly at the 2-hour mark.
So John, let's let's discuss the results of the poll, and let's try to close this session today. Go ahead.
So this question was presented to us presented to me by Jim a bit earlier, and it's a very quick summary of a discussion we had, which is, given how the things are changing now, I guess the question, I think you asked this really interesting question: should we now consider an HMD as a compulsory piece of equipment for all executives, design engineers in the organization who are going to basically want to be involved in these reviews? And it looks like we've got our answer here from our audience, at least. But 91% are saying yes, that should be true. I don't know how do you think that result is a surprise, Jim, or?
No, and it leads me to want to buy some shares in Facebook, or maybe
It's a very interesting point now, given that Facebook have just said they're going to be recruiting about another 10,000 people in Europe to populate the multiverse. And there was a general question, I think we were asked earlier, about whether the announcement from NVIDIA last week that they are creating a multiverse for engineers, which is going to be very interesting for mainly for consolidating sort of visualization 3D type CAD models. But I think it's a good starting point. I think this could impact once the big investors come in, the big companies start to come in like this, it does create a step change in the market. We saw this with HMDs when Facebook jumped in. We're now starting to see it with NVIDIA and the likes creating these omniverses, which is effectively the big cloud-based VR systems. It's primarily for games, but when they start saying omniverse for engineers, we start thinking, this is actually a big step change in the market. So have we got the results of the next one? Okay, how do we motivate legacy engineers to embrace distributed VR? So this comes back to the question, I guess, you've posed, I think, Stuart, and we kind of proposed a few potential solutions, but it looks like the majority is as we said in the panel, we need to educate, we need to train, but most importantly, we need to show the value through demonstrations. ROI less so, but it's more showing the value. So I think that pretty much it runs, I guess, agrees with the way we were going with the conversation as well. Has anyone, Stuart, have you got any thoughts on that one?
Yeah, I think it's interesting. It's quite close, really.
Yeah.
And interestingly, the lowest scoring is the return on investment.
Yeah.
I find that quite interesting because in a world where every cent counts, when we're the volumes that we're at, it's interesting that the general consensus of return on investment, and I find that really encouraging, because sometimes the world is too much focused on we must get the return on the product to make it work. And it's a pet complaint and hatred of mine in many ways, is that some things have a return, everything has a return on the investment to make it worth doing. But sometimes you won't see that return immediately. You have to invest and you have to move forward, and your return on investment will come. It's not going to be, you've got to have a return on investment to do it, and I think it gets stuck in that world far too often.
Absolutely. And I think it's quite, I think it's very interesting that it's almost like it comes back to the point Dimitri made earlier on at the very beginning about the McKinsey report, how time seems to be more important than money. We're time poor, but cash rich in some industries. So it's about using the time more effectively. And this almost sees that people are thinking that these products, these technologies, they speak for themselves. The ROI is almost obvious. It's just if you can show the value, the ROI becomes a kind of no-brainer. And I think that they speak for themselves pretty much. We saw it ourselves when we saw Paul's demonstration. The technology pretty much speaks for itself when you see it demonstrated, when you see what you can actually do. People get it, people can see. And it's about spreading that message, I think. So yeah, that's a really interesting result. Okay. So I don't know if we have time for much else now, Dimitri, but I think maybe we're way over already.
Yes.
So maybe it's worth me thanking everyone on the panel. Thank you, Jim. Thank you, Stuart. Thanks, Paul, for contributing to this discussion. I think it's been really interesting. I think we've touched on all the major topics as well, so we couldn't have asked for more, really. So thank you very much for the discussion. And I'll hand over to Dimitri just to finish up and finish us up, really.
Thanks, John. And well, thanks everyone for being here. Special thanks to Stuart and Jim, of course, and the other speakers and panelists. But most important, thanks to all of you who stayed on. We started almost 2 hours ago. And it's extremely exciting to see that you found value in this session. So thanks for that. We will find a way to answer a lot of the questions because there was so much engagement and we only touched the surface there. So we will circle back with the team and see how we get this answered, but also how we can find other ways to engage and continue this learning experience. So final request. Stay tuned with us. Follow us on LinkedIn. There's a lot of stuff happening. Thanks again. Have a great day. Stuart, Jim, Paul, John, thanks a lot. And
thanks,
we're
everyone.
looking forward to seeing you at the next session. Thanks, everyone.
No worries. Thanks for having me.